Let me introduce myself for those of you who don't know. My name is Abby. I work with Barry Cranford, who's the founder of the London Java community, and I have the privilege of hosting today's event. The London Java community is just one of the communities that is run by RecWorks. We are a tech recruitment company with a massive, massive difference. So as a company, we believe that recruitment really can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development. If people want to learn and others want to teach, we are happy to connect you through our communities and events. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. To date, for the LJC, we've run over 700 events for engineers, developers, students, graduates, CTOs. We have run conferences, lightning talks, hackathons, all sorts. In January of this year, we made our 4,000th introduction through our Meet a Mentor program, and we're really excited about that and seeing where that's going to go next. As I've already said, we love to give opportunities for people to connect, and this event is part of that. If you would like to know more about any of our other communities, we currently have about 15. Please do get in touch with myself or Barry or Helen Lewis if you know her, and we can send you the link for the right groups that you're interested in and take it from there. The recording of today's session will be on YouTube, so I'll be able to put the link in the chat later, and also you've got the option, just message me and say, hey, can I have that video, and I'll send it to you as well. With no further ado, I'm going to hand over to Ari, who's going to have a little word with us about JFrog, and then we'll hear from Sven. Over to you, Ari.
Thank you so much, Abby. I really appreciate it. Hi, everybody. My name is Ari Waller, and I am the Meetup Event Manager for JFrog. And we are so glad to be a sponsor with the London Java community this year. Just really appreciate the community efforts that Barry and the whole team just put into making it special and really uniting, actually, the recruiting world with the meetup world, which is not an easy task. Because giving back to the community is more important, because recruiters are usually just about jobs, but this shows a different heart and a different approach, which is really, really awesome. So kudos, Abby, to you and the team. For those of you who are not familiar with JFrog, we are the DevOps software company. We've been around since 2008, and many people, including you, may know us by our flagship product, Artifactory, which was originally written in Java, and is considered by most as the gold standard for managing your artifacts and dependencies. JFrog has always been committed to the Java community. We developed a free cloud version of JFrog for you specifically to enjoy, and it's free to use for all of your projects or just to play around with if you're getting your feet wet in DevOps a little bit. No credit card is required at all. And it's not a trial version that runs out. It's one that if you continue to use it, you can continue to use it as long as you like, as long as it meets your needs. I'll drop the link into the chat shortly. But something else I'd like to share, if I can share my screen really quick, is a really cool offering. In the spirit of community happiness, which is one of the virtues of JFrog, that I get to live and breathe on a daily basis, we have, can everyone see my slide okay? Great. We have a raffle just for attendees today. JFrog is going to give you a chance to enter and win a pair of AirPod Pros. It's going to be given to somebody who is here today, or tonight rather. All you have to do is enter with the QR code or the bit.ly link, which will also drop in the chat shortly. Now, because it's the internet, I can't do live drawings and sweepstakes. It's a compliance thing. However, a winner will be randomly selected within 2 business days of the meetup. And then once the winner formally accepts the prize, we will share their name with the entire meetup community and celebrate with them. But again, thank you. And without any further ado, I'm going to turn it over to Sven Ruppert, who's going to be talking to us about mutation testing, hunting the bugs.
Hello. So, thanks for the introduction. And now we want to start to talk a little bit more about the technical things. And today, talking about hunting bugs and this with mutations. So now the critical task. I have to share my screen so that I can start. And Voila. So hopefully you can see my screen now. I'm now searching for the chat window because it's always disappearing if I'm starting to share something. And let me see, all in the meeting. Okay, so by the way, if you have any questions, recommendations, or whatever during the talk, please just use the chat window. Don't use this Q&A thing. I'm mostly just looking at this chat window. And if I'm at the right time in my talk, then I will give immediately an answer, maybe a little bit later. But yeah, I try to give answers to everything what I'm seeing here in the chat, and that is more or less related to the talk. And yeah, so feel free to use the chat, please. So, mutation testing. By the way, my name is Sven. I'm from Germany, and as you can see at the picture, every 3 minutes I'm spending outdoors somewhere in the woods. And since the big pandemic, I have the pleasure to combine my hobby with my business or with my job, because I start doing all my recorded talks out in the woods. So if you want to see something about Java or DevSecOps or cybersecurity topics, then it would be a pleasure for me to see you on my YouTube channel. It's a tiny one, but yeah, I'm still working on it. So if you want to see some outdoor style IT talks, check out my YouTube channel, and I really would like to see you as my new subscriber. Okay, but now we're talking about mutation testing. Mutation testing, I want to go through several points here, and the basic thing is more or less why I created this talk. This talk was created out of pain. So I was head of an R&D department, and I had to work on a product, a legacy product, nothing fancy, startup, 6 months old thing with the latest technologies. It was really an old legacy project, and it was way over 10 years old. And yeah, it was a formerly product that was converted from PHP based Java, and all the developers, or the most developers that worked on this project, were still from the first team, all converted Java developers from the PHP world, and they learned Java inside this project, with this project, during this project. And it was a product that was sold to big companies. And yeah, well, but the cool thing was that there was really zero test coverage. So during the time I jumped into the project, it was my task to, yeah, clean it up, make it new, make it fancy, and all this stuff. And yeah, so there was really zero line of test coverage, and there was no dedicated refactoring budget. So they were just paid for features and not for cleaning up and all this stuff. I mean, the most of you know what arguments and discussions you can have with some people in your company. And for sure, during the 10 years of learning and development, the complexity of this piece of code was just amazing, really amazing. So for me, it was more or less a few questions I had. Say, what's the right place to start inside this project to get an overview where the biggest risk in this huge code base. And one of the big things was how to motivate this team to change something, to work on it, to make their life easier. I have to say that this team was, I think we calculate 70% or 75% of the developers in this team were in their last 10 years before they are retired. So it was really a dream to start in this project. And yeah, so I had a bunch of experts there, and I haven't test for you by yourself. So please grab a piece of paper and a pencil, and then give me answers to these two questions. This is a typical piece of business code. Why? Because it's completely random. There's no rule, no mathematical background that you can use to verify this. Okay, it's just some piece of business code. and it's a small part. And you all have to do with code reviews, and then you have way more complex code, I hope. And then you're looking at this code, and then you have to decide quite fast, is the test coverage good? How many tests you need? And what are the right input values for this piece of code? So just a test for yourself. We will go through this example a little bit later. Write down just how many tests you need, because we need this amount for some calculation. And then just write down the pairs of input values you would use. And I guess a lot of you are quite senior, so it should be an easy task. And just write it down. I mean, you have for this amount of code, maybe a minute, maybe two. During your code review, you will have way more code in way less time. So yeah, write it down. Give me a hands up if you have done it, so that I can just see that that it's done more or less, or that a few of you have done it. And during the time, I will start yeah, talking a little bit about it. So please grab a minute, write it down, and just give me a hands up if you're done. Or hands up if you don't want to do it, then just signaling. Okay, it's on. So that I can see something. Okay. I mean, okay, first one, I got the first one. More. Have, okay, I have a few. Okay, I got a bit. Okay, so let's work on it. I mean, why do we need this? What is the importance of these numbers? Why you should extract this so fast? If you have a test coverage, we have to find out what test coverage, how much tests are enough to test this piece of code. Okay, and in the same way, we have to identify, is this a good value? Okay, so we want to guarantee a constant quality of this testing environment, or this test coverage. So how to find out what will be enough? So how many tests I need to be on the safe side, and how to find out what are the right tests, and what does it mean? So in this, every day. So on Monday morning, on Friday, in the middle of the night, if you have challenges at home, if you're not feeling well, if you're highly motivated, whatever, we have to deliver constant quality, and this is something. Okay, so I think everybody had enough time to write his own examples down, or the input values in the month. And so I started for this piece of code with these two tests. So just 0, 0 and 3 and 0. And is this good? Is this right? Is this something we can improve? This would be the first question, or we have to find an answer to this. So before we are going through this example, I want to talk about the basic idea behind mutation testing. So mutation testing itself is something that is a structural testing method. It means you try to make sure that the tests are fitting as best against your code. It is not a test method that will help you to check if the requirements are got right or whatever. It's just the combination between the test code and the code you want to test. And the test should be as tightly bound to this source code as possible. It's a way to find good tests, technically good tests. We are not talking about the use case, or if the use case makes sense. Really, just we are talking about the technical aspect. So, and the good thing is that the machine will help you to find these good tests, and this is called mutations. So what is a mutation? A mutation is a change inside your own code, and it's small enough so that's a defect. What the defect is, we're talking in a few minutes about. So it is a change. So you have the original program, and then you have a program 2, and this is with one small change compared to the original. Okay, so with P the program, with T the test collection, so the amount of all tests we have, so the minimum that we need is one test, okay? Even if I have one test, I can start with mutation test. And then I need a sequence of modified programs, and this is called P1, P2, and so on. So, and in every mutation, I have just one mutation. Okay, I have never two defects in one program. I've always just one single mutation. And then I'm testing against this single mutation. What's good, what's bad? So if green is if at least one test will fail, okay, from a test suite. Red is if all tests are green. What does it mean? If you're changing your program from P to P1 with one single defect, and you let your test suite run and all tests are green, the result is that you're not able to decide if you're delivering P or P1 or P2 or P3, okay? So you're not able to identify that there is a change. And test coverage should be so near or so tightly bound to your source code that even the smallest change could be detected, okay? So the optimum would be that I'm killing 100% of all mutations, okay? This is an ideal world. The same with all other test coverage. We're mostly not reaching 100%, but this is the optimal goal we try to reach. So as many killing mutations as possible. So now the big question is, how should I create all these different mutations and what mutations are here? So what can we do here? So the general workflow is quite easy. I'm generating all the mutations, then I'm running all tests, and then I'm checking reports. And this is more or less a classical TDD process. So I don't have to change anything. I don't have to do separate steps. I'm just doing what I'm mostly doing with a tiny add-on that I decide now it's time for the mutation testing. Please generate all the mutations. Okay, but I'm using exactly the same tests. I'm using JUnit. What I'm using here. So, and the cycle is that after checking the report, I'm just changing the tests, writing more or removing tests. So it's really until my quality gate is reached. So it's no big change in your process. Okay, if I want to compare, or the first thing what I can do, if I'm now able to identify how many mutations I have in 1,000 lines of code or dedicated amount of lines of code, what I can do here, I can use this as some metric. Assume that I have 3 modules, and in these modules, I have a different amount of mutations, possible mutations. What I can do is that I can use this as a complexity metric or some kind of complexity metric and see if I have a module with hundreds of possible mutations and I have a module with just 10 possible amount of mutations, then this module with 100 amount of possible mutations is by far more complex. We'll see why it is like this. But if I have this one, I can use, even if I'm not even killing one mutation, if I'm just generating the report of mutations, I can decide now in different modules where is the biggest technical risk in terms of amount of mutation. And this is mostly a direct indicator to complexity or not well-written code. Okay. So if you have this, just have in mind that you can start structuring. So if you have different modules, focus on with the most mutations, possible mutations, then you have even a strict order between modules. But what is a mutation and what are different mutation groups, language dependent, language independent? So what can be a mutation? For example, we have value mutations. Value mutations is that inside a loop boundary, for example, I'm changing the number, run until 3, run until 4, without now using some language construction. It's more or less language independent because all languages with loops can have this mutation. Changing constants, I can just change them from -10 to -1 or to whatever. I have decision mutations. Decision mutations are smaller to smaller equal. So logical operators that I'm just changing, okay, or I'm negation, or something like this. The same, and what I have that is language independent is something like statement mutation. It means that I'm swapping, deleting lines of code. So it's something that you have sometimes from refactoring and all this stuff. You're changing lines of code, or you're duplicating things, or whatever. So this you can do, and this is called as mutation. Okay, value mutation, decision mutation, statement mutation, and these are language independent mutations because you can do it with all languages, I know. And then you have language specific mutations. And now we are talking about more Java specific thing. By the way, the most stuff I'm talking here saying is for Kotlin as well, or other JVM languages. And yeah, we will see how to use it. So for Java, think about changing modifiers, or you can delete initialization of members, or changing between static, non-static, and all this stuff. What's really nice, and what the most people are not thinking about, is, for example, my favorite one is argument order change. I had fans of clean code in this team. Clean code was everything, but clean code was a little bit misunderstood at this point. So I had methods, for example, with a signature method name, and then the arguments were integer A, integer C, and integer B. And they had the same range of possible values. And then clean code was very nice, and they thought, okay, changing the arguments would be interesting because A, C, B is not good to read. I'm changing it now to A, B, and C. Great. It was really great. So finding these bugs was pain. Took really time. So all these are Java-specific mutations. Depending on the mutation testing framework, you have more specific ones, and sometimes you can create your own. But this is more or less the idea behind it. So you have source code, and then you're changing in tiny bits and pieces this code, creating the new version of the program, and then let the source code, the test suite, run against exactly this modified program. So mutation testing, as I mentioned, is an add-on to the normal, regular TDD stuff. So if you're have the test-driven development, you're on a very good track, and then you can just add mutation testing on it because it's just an add-on. It's not a change. You will see that we have tools that is supporting it very well, and there's a downside of it. I will show you examples later in terms of time. Generating and running all tests are very time consuming. So it means if you have 100,000 lines of code project, it's not a good idea to start mutation testing on your CI environment on Monday morning over all packages with all mutations. Will just not end. Okay, so start in tiny modules and see what is the runtime behavior for your project before you're just using mutation testing for the whole project. Okay, you can do it on a dedicated machine, but not if you have just one CI environment with one agent or something like this. So have in mind that the runtime of mutation testing is something exponential with the amount of lines of code and the possible amount of, well, not the amount of lines of code, more or less the amount of possible mutations. Okay, so, but mutation testing will definitely affect your project structure if you start working with this. So, okay, we have this mutation term. We have now the different mutations that can be done. I showed a few examples. So what is approach, for example, in Java to work on this, and what frameworks we have here? So there's an old framework that is just for research purpose. Never use it. Okay, please don't use it. It's end of life. Don't use it. But if you want to learn more about how to write mutation testing tools, it's a good thing to check. So I saw that a lot of projects started around 2003, 2004. I guess it was fancy at conference to talk about. It was, I don't know, sponsored by companies, research institutions, whatever. So a lot of frameworks started 2003, but the basics, the mathematical basics behind mutation testing is from the 70s. So the theoretical part is very old, in computer science ages. But in Java, it started 2003. Then a lot of frameworks started, and they all died around 2008, 7, 8, 9. So in this age, the most project died. I don't know, maybe they are all having the same results or whatever. And this framework, what I'm showing here, had the approach that they start modifying the source code and then try to compile and let it run. And the challenge here is if you're creating mutation and this will break the compile process, you have to decide, is this now an error that is done by wrong syntax, or is this a runtime error, or what kind of error it is? And this is sometimes not so easy. So it means mutation testing you can use for the most languages from the theoretical point of view. But if you have languages that you have to compile first before you can run, then it's not very effective. So for C, C++. But I know mutation testing is, for example, used for PHP as well, and inside the JVM. So this project is still available, so in terms of source code, and then you can have a view on how to decide how to create mutations. This is interesting. And a good mutation test framework, the quality you will see in the way how many mutations that are repetitive or overlapping are just not executed. So this is a quality mark for mutation testing. But there is another framework that is very active, and they started around 2012, if I'm informed right, and it started as a parallel integration test framework. So this is where the name is coming from, PyTest. It's an open source framework. The main coder or the inventor of this project got his Java champion for this, I don't know, 2-3 years ago. I'm not sure about that, but got his Java champion for this. And since 2014, it's very active. So if you have a new Java version, then it's very fast adapted to the new bytecode, because the big change here compared to the other project is that this source project is working on bytecode. So it's getting rid of this compile context in terms or in a way that it's just changing the bytecode and then let it run. And this is a very good approach for Java or all JVM-based languages. And we will see that we can run it on Kotlin as well, and so on. So PyTest came from the parallel integration testing. So that means the project was very strong in isolating class loaders, ramping up different processes, let stuff run, check if the process is still active and all this. And this helps a lot with let mutations run concurrently. And yeah, it's very, very, very cool. So looking at it, how it looks for you as a developer. We're going back to this example. So we have this method with 2 ints, with just a few logical operations. And now the question is, how many tests do I need to test this piece of code if we are thinking about what is the total amount of mutations here? What are the pieces that can be changed in what way, and how to isolate this one with one single test? So now the big question is, how many tests I need, and what are the right input values? So if you're talking about line coverage, pure line coverage, then I need exactly 2 tests. Why? Firstly, people are looking at the source code, and this is a good advice. The first thing what you have to see is how many paths you have through the source code. The maximum dominant part here in this source code is this if construction, and this will lead you to 2 paths. So you see, okay, I have 2 possible paths. So at least for 100% line coverage, I need at least 2 tests. If I have just 1 test, I'm below this border. So my test coverage is per definition not good. Why should I think about the minimum amount of needed tests? If I have the rule that every test will cover just 1 case, I need to understand immediately how many possible paths in this piece of code, how many tests I have, and this is the lowest barrier I need. If I have less tests, I'm below the minimum quality. Okay, that's it. So the next thing is, how can I identify the upper border? So what is the amount of tests that are needed without writing too many tests? I saw, for example, for this example, I saw sometimes that people are writing 30 or 40 tests to test different things. And imagine that if you would have this amount of tests for this tiny piece of code and this in a bigger scale for a project, you would create way more source code as your original program. It's okay, but you have to maintain all this stuff. So it's not good if you're just adding tests, if you're just constantly adding tests. Just imagine if you want to switch from a JUnit version to the next one, and you have to migrate your tests. If you have to migrate to new language features, behaviors, whatever. So make sure that you are writing the good amount of tests, but treat this test code as it is your production code. So test code is your production code, and with this you're producing the production code for your customer. Okay, so you need something to identify how to remove this test. So let's start with these two tests, 0.0 and 3.0. So what is good, what is bad? If you're talking about line coverage, then I will get with Jacoco. By the way, Jacoco is a very good tool. It's the best tool for line coverage, I know, including branch coverage. I will get with this test here with 0.0 exactly this report. What I see at this diamond, so with pure line coverage, I would just see that 6, 8, and 9 is green. The rest is maybe white or red. With branch coverage, I will get at least the idea that I'm not covering all passes. Okay, but that's it. If I'm adding the second test, 3 and 0, I have 100% green line coverage report. Okay, but with this test, I can do a lot of stuff. Now looking at this mutation testing stuff, I'm adding now to this PyTest configuration. I'm just using the default PyTest configuration. I have this conditional boundary, increment, return value, mathematical operators, and so on and so on, a bunch of mutators. You can switch up and down if you want to add more or want to do it. And then with Maven, I created this PyTest mutation coverage tool. So what it's saying to me is it's generated 54 theoretical mutations for this tiny piece of code, okay, and killed exactly 3. Wow, that's amazing, huh? So, but talking about the quality of mutation testing frameworks, from the theoretical amount of mutations, reduce it to effective mutations, and this means that this huge amount of mutations, theoretical mutations, it was reduced to 4 possible mutations. So good mutation test frameworks are excellent in reducing the theoretical part to the amount of mutations to the really active mutations or important mutations. So what I see here is that my line coverage will show green, okay, and my mutation test coverage says, okay, I have 3 mutations out of 7 active mutations. So you will get this HTML report out of PyTest, and then you have this class name and you have these 2 metrics. And if you're clicking on this class name, the service to Java, you will jump inside this report to this detailed view, and then you see per line different things. For example, you will see that line number 8 will have 2 mutations in this line, and what kind of mutation you have. For example, here you have changed conditional boundary and negative conditional. So these are the 2 possible mutations that are identified with configured mutators for this line number 8. And I killed exactly with my test the second mutation. So if I have this one, what I'm doing now is I'm looking at this report. Then I identify, okay, what I want to kill as next. Then I'm focusing on one mutation I want to kill, and I'm changing a test or I'm adding a test. In this case, I just switched from the values 3 and 0 to 2 and 0 because I want to go with my values as near as possible to this logical operator smaller equal or smaller, so that if this is changed, immediately it would fail. Okay, so now line number 8 is green. Both mutations are killed. The next is I'm removing 0, 0 and adding the test 1, 1 because I'm killing the mutation number 1 in line number 9. Okay, replace integer with subtraction. Okay, so the next one would be killing the input values 0 to 2 and 0. And now I have the pair 1, 1 and 2, 2. And with this, I'm killing line number 11, replace integer with subtraction. Okay, so now I have 2 tests with 2 input values, definitely different than what I had before during the time I was working just with line coverage. And now I'm looking at this one. You will get with mutation testing immediate, you will get some points like, oh, here's a mutation I can't kill. Here, the mutation I can't kill is multiplied by -1 because divided by -1 and multiplied by -1 is the same result. So you will get here to this point that you can't kill this mutation. You will have more complex examples in your business code later on, but you have to make, as always, the decision how to deal with this. And you have different possibilities. First of all, you can just ignore it. The other possibility is that you try to rewrite your code. So with mutation testing, immediately you start writing easier structured code to get rid of these not reachable mutations. Okay, so what we learned here was more or less, this is a piece of code from this legacy project. With everything what we learned so far, how many tests I need for this piece of code. This was a utility function and it was spread over the whole project. So I got the allowance to use this piece of code for demonstration purposes. So I took this piece of code and I took one of these old engineers and told them, okay, write the best source code against test coverage against it. And we want to refactor this piece of code to understand what's going on and to make it more simple. Okay, so how many tests I need? What are the right input values for this test? Well, if you want to refactor this one, you have different possibilities. You can just refactor because you know exactly what this should be doing. Okay, well, basically it's not the case. Huh? And then you start modifying the source code. In the end, what you need is a semantic equal implementation of the original code if you just want to replace it with a more cleaner code. So you can use 2 implementations, let it run forever against each other and check if there's any difference. Well, on the other side, the best thing, your best safety belt here is just a good, strong test coverage. So with mutation testing and this piece of code, we were able to, with this piece of code, with this isolated piece of code, we have done a brute force attack with these 2 implementations. We just let those run with, I don't know how many input values against each other to compare after the test phase and refactoring phase, if it is the same, something what you're not really doing in production, but for this training purpose, it was possible. So, but in the end, writing again this one, the best test coverage you can, and then rewrite the source code. And this was the result. So this is the same functionality in a different piece of code, cleaned up so that you are able to kill the most mutations here. And if you're comparing those, you will see that the complexity in terms of if then else and all these subfolder strategies here, they are way easier. So the version 1 was for loop with if and cascaded if stuff. And the second version was 1 if else, 1 for loop with 1 if inside, and 2 additional if else, independent if else structures. So what you can see with mutation testing is if you start with mutation testing, you start writing the simpler code with the same behavior. And this will lead you to better mutation test coverage, way stronger mutation test coverage, or test coverage in general, easier to maintain code. And those is done by a developer because he's just want to get a good test coverage. Okay, it's not per definition because you have to or whatever. So mutation tests are often leading to cleaner code compared to JUnit only or line coverage, and it will affect the structure. So people, the developers start writing smaller modules. This is more or less based on the exponential runtime behavior of mutation testing. So if they are lazy, they're just making shorter modules so that you're working fast. And there's one interesting thing. If you're looking at this piece of code, it's a typical piece of code. And normally you don't have this red-green highlighting, but here is useless code. In this piece of code is a line that's completely useless. So what it is, so how to find it? Well, if you're looking at this code, maybe you will find it, maybe not. If it's a little bit more far from each other away, then you're not able to see it straight. But with mutation testing, you're able to find it quite fast. If you're looking at this, so I'm just zooming in to line number 18 answer. Mutation testing will say to you, you're not able to kill those mutations. Why? Sure, it makes no sense. So asking if something is bigger than 0 and then iterating over it makes no sense. So what you will find is more or less that code that is just inside your application. So it will not only help you to make it cleaner or more structured, it will help you to identify useless parts as well. Sometimes small, sometimes less, but it's a nice add-on. So talking about all this, why is mutation testing helping, and what's a good thing? If I'm talking or checking what I'm doing as a developer, I'm writing my own code, and then I'm adding a bunch of dependencies. Okay, this is what I'm normally doing. I'm adding a dependency. I'm adding the dependency of a PDF library instead of writing a PDF library by myself if I need it. This I'm doing over all tech layers, but we are focusing now on the application layer. Okay, I have two things that can hurt me, and this is compliance issues with dependencies. Okay, wrong license, or they change license, and I have to remove it. I have to replace it with a semantic equal implementation. I need a very strong test coverage that's supporting it. If I want to get rid of vulnerabilities, it's more or less a daily job for us, because we have found new vulnerabilities. I have to change dependencies. Now I need a very strong test coverage so that I can change my dependencies, not only the top level dependencies, even transient dependencies or indirect dependencies, because then I let the whole test suite run. If everything is green, it's nice. So as an example, if you're inside your ID, you see that my dependency will have some vulnerabilities, and I can't change to the new version because it's not supported so far, or the vulnerability is not killed, or whatever. Then I can kill maybe vulnerabilities if I'm working on the vulnerabilities or the dependencies that are indirectly used. And then I need very strong test coverage. Okay, so it means even in my DevSecOps or security or cybersecurity related talks, I'm mentioning that mutation testing is one way to have a very efficient dependency management, because this dependency management, or this test against functionality you are really using, is not only how to test my code, what I'm writing, but you have in the same way the possibility to change the dependencies, the composition of the same dependencies with different versions in a very effective way. And this is mostly helping killing vulnerabilities and compliance issues as well. So good test coverage is not only for testing your own code. A strong test coverage is good for a lot of different things. So quality and security, for example, going really hand in hand here at this point. So how can you start in your own project with this? You can start in your project here. If you have JUnit and you want to start, you need this PyTest plugin inside your Maven definition. You're just adding it to your project. The configuration I will show you is just a copy paste. It's really easy. And then you're creating the reference. It means a clean install or clean verify. It depends how good your lifecycle is. So, and then you need something with 0 red tests. Okay, so mutation testing is not possible, or it can't be used if you have failing tests. Okay, so you need a green test suite for the original program. And then you're running this target mutation coverage, and then you will find the report on the target bit reports. You can have it in XML and HTML, and so it means you can use it for your daily, if it is done by the CI environment, or you can feed other report or tools for this. The configuration itself is just copy paste. You will see on the homepage from this tool that they have exactly this snippets. You need once the declaration of the plugin, and then the plugin of this reporting. The only thing what you have to do is to decide XML and or HTML, and you have to define your target class, your production classes, and your test classes. Okay, so reporting plugin, that's it. Then start with some tests. You need just one test. Then you're generating the report, and you start writing the next test, and that's it. And if you have time, you can use mutation testing in the same way that you try to eliminate useless tests that are overlapping from the values. Okay, and this step by step. About runtime, I have a kind of project for myself. It's a dynamic dependency injection framework. I use it for some projects, and I started with mutation testing during the time I started talking about it. And here, what you can see is that the JUnit runtime is nearly 40 seconds. Okay, not so much. But with mutation testing, I have 3.5 minutes of the same code base, and we are talking a few kilobytes of code. So really make sure that you try to minimize the amount of the scope during the first time you're running mutation testing, so that you're not running an endless time. So mostly it's in a way the source code you're working on yourself. So this tiny one, you're working with mutation testing, harden this one, and then in a regular cadence, you can use the CI system to do this long running mutation testing of the big project or bigger parts of the project. I see that sometimes people start comparing different line coverage tools, and this makes no sense. So you will find different results somehow. For example, if you're comparing from Jacoco and from PyTest or whatever tool you're using, different line coverage, then it can be that you have different numbers. Don't try to make them equal, don't calculate. Decide if you want to use line coverage or if you want to use mutation coverage, and then just use this one. So don't try to compare these metrics against each other. Here in a Java class, I just created this one, and I created as same in Kotlin, so object-oriented version in Kotlin. What you can see is that PyTest is working on both, so Java side as well as on Kotlin. So you can use it for transition, for migration, or for mixed project as well. So that's very, very convenient. So here's the output of the Java class. We'll complain this integer multiplication with division, and the same is complained in the Kotlin code. It's a little bit different in terms of lines of, that are complaining or at what place the mutation is possible, but you will get more or less the same result or the same report. So this is very convenient because you can use it for different tools as well. So I'm more or less done with the topics I want to explain. It's a short overview. I really can recommend going to pytest.org to see how it works, how to configure it. It's a very straightforward thing, and the initial effort to try mutation testing mostly is just a few minutes, because you are adding copy paste something to your Maven file, then you just let it run. So that's it. If you have any questions, I'm checking in the chat. No questions so far, but if you want, you can connect to me later via Twitter, LinkedIn. I really would like to see you on my YouTube channel for sure. And the only thing that is really bad is email. Email is just not working for me. Okay, so then I'll stop sharing my screen. And
Fantastic. Thank you, Sven. That was brilliant. Love it. I love it. Does anybody have any questions?
no questions.
There is one that's just come up in the chat.
Simon. Yes, Simon. So, what with language-specific mutation changing public to private, static to non-static, compilation will fail. So the thing, PyTest is not compiling your source code. It's just modifying bytecode, and it could be that it's just crashing. Yes, but then you're killing a mutation because it's crashing. Okay, but it's definitely because the bytecode is, or the result is not runnable. That's it. Okay. So it's a big difference if you try to modify source code and then doing the compile process instead of just modifying the bytecode. I hope I could give you a proper answer. So sure, I would have liked to have seen a comparison with using switch instead. Yeah, so I keep it simple, I keep it short in this talk so that everybody from just starting with Java up to an expert is able to follow. So sorry for having this very reduced, in terms of complexity, reduced examples, but just try it out. It's easy, and the report is giving you the line numbers and all this stuff. So, and then it depends on what Java language you're using. So what are the features, how to do with records and all that stuff. But in the end, PyTest is following up the bytecode very fast. So mostly if you have a new JDK, if it is done already or just in a few days, mostly it's adopted, and this is really cool. So if you need this tool. Okay, are there any IDE integration for following the mutation loop? Yes. So for IntelliJ, there is a plugin available. I don't know the name because I'm so lazy. I'm just using my JUnit thing because I'm just saying generate this one, and then I have my browser with my HTML report. But I think there was for IntelliJ at least a plugin that was working with JUnit 5, giving you some kind of line coverage indicator and all this stuff. So it's there. I'm not using it. So okay, integration with IntelliJ. Yes. So integration is more or less it's based on your build system. So if you're using Gradle or Maven or whatever, it's just part of the definition. It's just a target you're running. So integration is there. What kind of integration we could have? Maybe something like highlighting if this is covered or not covered. I'm not sure if this plugin is doing it right now because I'm not using it. So sorry. It's but I think someone will work on this topic for sure. And if you found something, please let me know. Just mention it on Twitter or whatever and ping me back, please. So any other question? No questions so far. No, I didn't know. Okay.
Okay. Well, all that's left for me to do then is to say, if you want the YouTube video, have a look probably early next week. It should be on our YouTube channel, or message me directly on LinkedIn and I'll be able to get that sent to you. Thank you so much, Sven, for sharing what you know. And thank you so much for sponsoring us as well, JFrog. It's always been a pleasure so far, and it's always great to hear you speak as well, Sven. And thank you to everybody who's joined us today, and we look forward to seeing you at our next LJC event. Thank you very much. Have a great evening. Take care.
Bye.
Thanks, guys.
Bye.
Bye.
Yeah.